Alright, so Assalamualaikum. We are from Group 7 are going to present about our second assignment, which is Recyclable Material Classification by using Convolutional Neural Network CNN. So our group members are consist of three members, which is Muhammad Hadif Shahmi, Muhammad Khairan and also Muhammad Faiz. So for introduction, the municipal solid waste production is increasing in recent years. The recycling is a manual process that not entirely automable. And then the different types of waste must be treated in various ways. So that the waste management includes waste segregation, which is crucial, is managed by law because it makes recycling much simpler. So the effective waste segregation will reduce the amount of waste that will be sent to the landfill, and the most object detection systems rely on CNN because it can dump fewer recyclables in landfills. So with the help of CNN, it will be helpful in categorizing beverage containers because it helps filter and enhance image in terms of produce information for machine interpretation.
Hello and Assalamualaikum. My name is Muhammad Adif Shahmi bin Zamani CE200102. As a second presenter, I will explain about methodology. This group project aims to give a general overview of the procedure used to finish the project. It was complete in a variety of ways, including by running a simulation using Google Colab. Users of Colab have access to an online Python editor that allows them to create and run any Python code. So this is our task one, which is convolution neural network CNN. A convolutional neural network CNN, a type of artificial neural network, was created specially for handling pixel data in the field of image recognition and processing by placing the layer of neurons in traditional neural network in such a way that they cover the entire visual field. One can get around the piecemeal image processing issue that the plugs these networks. A multi-layer perception like system that has been developed for lower level of processing demand is the basis of the CNN. Layer of a convolutional neural network consists of an input layer, an output layer, and a hidden layer that includes several convolutional layers, pooling layers, fully connected layers, and normalization layers CNN.
Right, so for Visual Geometry Group VGG16 or VGG, it is an organization with a deep CNN, and it has multiple layers as its standard architecture. So when we discussing about the VGG16, deep refers to the 16 convolutional layers that make up the algorithm. So it is possible to trace all novel new object recognition models back to the VGG architecture as their source of inspiration. It is also thought to be the one of the most popular image recognition architectures now. And then the 16-layer deep neural network is referred as VGG net. Therefore, it has 138 million parameters.
Hi and Assalamualaikum. My name is Muhammad Khairan bin Sari. So for my part, I will present for the dense convolution network, which is DenseNet. A DenseNet is a type of convolution neural network that uses dense connection between its layers. Dense block which involve connecting all layers directly with one another, ensure that the feature map size are the same. And each layer receives additional input from all layers that came before it and transmit it to own feature map to all layers after it. So in the standard convolutional net uh, architecture, which is based on the figure above, the input image is subjected to the numerous convolutions in order to obtain the high level features. And each layer in the DenseNet network in figure above receive a new input from all the layers that came before it and then transmit its own feature map to the all layers that follow. And then concatenation has a purpose. Some of the collective knowledge of all the layers that came before it is passed down to each layer. Is for the so next is the network can be made thinner and more compact. or there can be fewer channels because each layer receives a feature map from other layers that came before it. And then the next number of the total number of extra channels that are added to each layer is growth rate, which is represented by the symbol K. As a result, it has a significantly better computational and memory efficiency. So according to the figure above, each composition layer is subjected to the pre-activation batch norm, which is Pn, ReLU, and 3 times 3 conversion algorithm before being converted from times 0, times 1, 2, and 3 into times 4. For instance, this is carried out to result in times 4.
So we continue to this part, which is task 1 CNN model. Step 1 is we connect to the Google Drive, and the output written is mounted at content Google Drive. Step 2 is feed dataset directory, which is we import operating system to get the direction to the file in Google Drive. So it written done here as an output, and we go to the third step, which is create training and validation data directory, where we initialize the training direction and the range direction. So the output is 156 for can training length, pet training length is 310, can val length is 77, and pet value length is 133. So the fourth step is import TensorFlow, where we import the operating system to get the direction to the file in Google Drive that has been saved. So the fifth step is where we construct the CNN model. So we can see here our input shape is 150 times 3, and it is to extract the 32 filter, and here extract 64 filter and extracts 128 filter, and before that we do the flatten and we go to the 512, the last one we dance with 1, and this is the output for step number 5, which is construction. So step number 6, we process the data, the input data, where all the image will be rescaled by 1.255. The rescale factor will be multiplied by this value before applying other transformation, which is the value that I've said before, 1.255. And the output is found 466 image belonging to 2 class, and also 210 belonging to 2 class. The data batch shape is 20 times 150 150 times 3. So the label batch shape is 20. So step 7, where we start the training process. So we are using a push, which means the points where the time starts, the returns value of the time, and this is the result for each epoch process. There are 20 epoch. So step number 8 is to plot the outcomes. Therefore we see the graph, and this is the graph for the training accuracy, and this is the training loss. So the last step is we need to test the image from 3 different position of the pet and can. So the first one, pet and can stay same direction from the camera screen. So the output says 100% can and 100% pet. So the second one, can stay 50 centimeter in front of the pet. Output says 100% can and 100% pet. And the last one is pet stay 15 centimeters in front of the can, and also the output says 100% can and 100% pet. So I think that's all from me. For the next part, I will pass to my friend, which is Muhammad Faiz Amirudin. Thank you.
Right, so for the task 2, we are going to use VGG16, and it has 9 steps for this task. So for the step 1, we of course we need to connect to the Google Drive, and then make sure that our Google Drive are connected with our main email. So for the second step, we need to feed the dataset directory. We need to import our OS, which is a directory from our Google Drive that have collab notebooks. And then after that, we need to create a train and validation data directory, which also from our the same G drive, and make sure that no error, because it will we will use this folder to execute the step after step 3. So the result will be like this. It will show the length of every train and also while of can and pad. After that, step 4, we need to import our TensorFlow. We will import from our Crush uh, applications, and then after that we need to construct our pre-trained model with VGG16. So the VGG16s will download data from the Crush application in VGG16 model folder, and then it will print the layer type and output shape, and then it will show the result of the total params, trainable params, and also non-trainable params. After that, we need to find the model of uh, sequential sequential type of VGG16, and then it will show the same parameter, which is total param, trainable params, and also non-trainable params. After that, for the step 6, pre-process the input data. After we put in the code in Colab, we must make sure that they have two elements that we need to find, which is train generator and also validation generator, and the result will be like this. For train generator, it will found 466 image belonging to two classes, while for validation generator, it will found 210 image belonging to the two classes. So after that, we need to start our training process by using this kind of code. After that, after we run the coding, it will show the process of epoch 1 until 20. After it comes to epoch 20 of 20, it will show the what we call it, the last value of step loss and also val loss. And then after that, we need to plot the outcome. We need to import the matplot library from PLT. We need to import matplot library from the Google Drive, from our Google Drive, which is Crush application. After that, it will show our training and validation accuracy, and also training and validation loss. So for the last step, we need to test with three images, which is both pet and can are the main model of our test. So for the first step, for the first test image, we need to display image from the same distance from the camera. So to make sure that the collab are reading the pet and can 100%. So after we run this, it will show this image is 100% can and 100% pet. After that, we need to find we need to declare, or we need to find the image of can stay 15 centimeter in front of the pad. So after you put the coding inside the collab, uh, the result will be 100% can and also 100% pad. After that, for the last test, we need to put our pad stay 15 centimeter in front of the can. So after we use the same coding, it will show the same result, which is this image is 100% can and also 100% pad. That's all from me. Thank you.
So now I will show some demonstration for the task 2 using the DenseNet. So first thing first, we run to the Google Drive, which is connected to the Google Drive that consists of input data of the training and also validation images. After that, we run for the step 2, which is we want to import the OS module to the Google Colab to looking for the directories. And step 3, we run to check and also set the training and also validation images. And also we can see the total images inside the directory, which is in Google Drive 5. And step E, we run to import the TensorFlow, which is important libraries. And step 4, which is we run in order to add in the pre-trained DenseNet to the Google Colab. And next, we run for the overall model with additional layers and also the flatter layer. And then we run to pre-process the train and also the validation data. And then we can start the training process, which this process might take some time. So there are 15 epochs, as you can see here. So the validation accurate is 1, and the validation loss is quite low. And for the next step is we run to plot the outcome of the model. So you can see the figure. There are training accuracy and also validation accuracy of the images. So and the last step, we have to test with 3 images. So this is the first images. And then run for the second images. And the last one. So that's all for the simulation of the DenseNet. For the last part is conclusion. So for this assignment, we have select 2 pre-trained model, which is DenseNet and also VGG. And also we know that the convolutional neural networks such as CNN, VGG, and DenseNet are frequently employed for the image classification. And also we investigate the recycling of PET bottles and aluminum can. And also we achieve the state-of-the-art efficiency while minimizing deep neural networks device train. And also we know that the VGG model is more complex than the DenseNet model. And the last one is this assignment have to comprehend the fundamental ideas behind the convolutional neural networks CNN. So I think that's all from us. Thank you.